Hey, how's it going? It's Sid Greenwood, and this is my Project 3 experimental phase. I'm working again with inverse kinematics using Unity's animation rigging system. And last week, I previously made these arms here that responded to the player movement and just kind of tried to add some juice essentially to what otherwise would be very static grapple looking arms. And now, this week, I went ahead and tried to make an actual walker. So, yeah, this is just a little example of how it behaves on different environments. Obviously, it doesn't look perfect and there's some glitchiness to it, but for the most part, it essentially calculates where legs want to go and then does some weighting and averages and then rotates the body to adjust to that. We'll get into that in a little bit. So, last week we touched on this a little, but I'm just re-updating. This is the kind of framework that Unity's animation rigging system uses. We do use an animator, but there are no animations attached to this at all. So it's not really like using animations or a bunch of built-in stuff besides the IK components. It's just kind of a necessary thing because there is an extension. There's, oh, sorry, another level where besides the procedural animations, you can start blending with real animations to get even more solid-looking effects. So the general idea is visualized here in all this debug information. So we start with this point right here, which we raycast downwards and look for ground. Pretty simple. From there, we take the hit, and this is the raw target place we want to go, but we do a lot of calculations to then get to this blue point, which is a way more realistic looking and better step point. It can be static or step target. What I mean by that is based on a few different variables that we can assign, we either make that point static so the foot stays there, or we animate that point in space to get a cool looking step. From there, we take each four of these leg positions and average them out, and then we apply a body height that we desire to it. That's visualized by this green location. The body then we move laterally either by input from like a player or from some sort of AI logic. Other than that, this green line you see here is taking the locations of each of those feet, and then we are taking the weights and essentially making a forward, right, back, and left weight. We then get the forward direction weight and the right direction weight, and then we can use that information to calculate a direction that we want the body to look. Let's do a code walk. So we'll start with the leg movement here. I'll show off the kind of parts that really make it work. First, there is this synchronous and asynchronous leg system I set up. This is a really easy way to just make sure that you can customize, which legs are essentially never going to step while other ones are, and which ones are always going to try while other ones are. This could be used to make like a spider wave looking step effect, or kind of the basic, four-legged walker approach that you see here. These are some kind of properties I set up to utilize that synchronization logic or knowing if we can step. And the meat and potatoes of everything is going to be in step right here. So essentially, we take a start and an end point, and then we get a midpoint and apply a height to it. Nothing too crazy there. But what is real nice, and shout out to Professor Bond himself for a little Bezier function here. We take the duration of the step we want, and then we plug in an array of vector 3s, which are the points, the start, midpoint, and endpoint. And then we can essentially do a really nice and smooth linear interpolation between those points. Um, by setting the last point in the array consistently, we can guarantee that the foot is always going to end up where we want to be. And because it is a linear interpolation function, it's going to look really smooth even with values changing. We also did apply some easing here, so just some different quadratic formulas to affect if it looks like, like a drag, like you're dragging the foot really slowly, or if you're really quickly snapping to there. So you can make everything from like a frog to like a zombie. From there, after we have a leg that is set up and behaves how we'd like, we can then take multiple of those, put them together, and then make something to manage them, which is this body movement right here. There's nothing too crazy to point out. The biggest thing that makes all this work is these averages right here. We assign a kind of leg type to legs that we want to have weight over the rotation position of the body, and then we do some calculations. So first, in the actual movement calculation, we have this right here. Essentially, we go through each leg, we add the weights up, and then divide it by the count of each leg type. And then for the rotation, we now take those weights and we change them a little bit to now not be leg positions, but actual kind of like lateral body positions, so like front, back, left, and right. We get the forward angle, the right angle, and then we get the cross product of that, and we get a nice rotation that we want to face. From there, we do a little bit of extra movement from input, either from a player or some sort of AI logic, and then same thing for rotation. And then the body will react to that based on the target position rotation and some lerping and slurping. Other than that, here's some attributions. I did have a nice 45-second demo that covered almost nothing, but it did actually give a lot of insight into what to do. And then there was a Unity tutorial itself that was a lot more helpful. Any questions?